So I want to start this lecture with talking about a concept called an entity, and you'll hear this. This comes from id Software, but it's a good abstract concept to work with. And think of it as an entity as something that's in your engine, something that you're interacting with in your game. And that's one of the best ways to look at that. Like a good example of an entity is the player model. Another example of an entity would be the projectile from the rocket launcher or the grenade from the grenade launcher. Um, Things that you can destroy in game would be entities as well. So the idea why this is a good term, because the foundation of Unreal Engine is that the designers are going to work in in respects to objects. And and so this is why and these objects basically are defined by, underneath the hood, it's going to be defined by code classes and C++ classes and blueprint classes. Where Unreal Engine goes is it's a mix of both of them. We're only starting with blueprint right now in this class. Um, But ultimately, the engine is built by C++ code and Blueprint working together. So now we're going to look at building actor classes. Again, actor being the first class which you can place in the world and be part of the world itself in some way. And these range from, again, the static meshes that building out the world itself, all the way to, again, player models and particle systems and whatnot. They're all some sort of an actor being placed in the world. Um, so in Unreal Engine 5, and this is how Unreal Engine 4 worked as well, is that your game objects, using the wrong term, your classes are built using components. That there are all these different components that you can add to a class that give it that define the class itself. And so that's the purpose of that's excuse me. Um, so by adding different components, you can build different things. Like right here, they've got static meshes and skeletal meshes. These are, again, what we talked about. They talk about a scene. So think of a scene as more like if I want this collection of things to move independently, locally of that object, I would make a scene for them and then parent everything to that scene, and I'll move the scene for those objects. This is equivalent in Unity. They have like an empty game object that you'd use to be like a holding. That's what a scene is. Again, they've got audio pieces. They've got planes and spheres and whatnot, and tons of just they keep adding more components for different systems. Um, Components viewport. So basically, you've got in your viewport. So let me actually bring up Unreal. So one of the things we're gonna talk about is there are three primary tabs that you're gonna start with. This is your class. Three primary tabs you're gonna start with when you create a new Blueprint class. So there's two ways to make. You can in the content draw go down and right click and add a Blueprint class. You can also do it here as well. And we're going to use an actor. Um, most of the time, if you're writing something generic from the scratch, it's going to be actor. But other times, you might be using another class as your base, and there are time and places for that we'll talk about later on. So I'm just going to grab the actor right now. I'm going to put it in content, and I'm going to just call this. Let's call it hello light. And so what the slide was showing is that there's the viewport here, there's a construction script tab here, and an event graph. All right, viewport. This is where you're building the object in terms of different components. And we go back to, let's make sure, back to the slides. So for here, they've got a capsule component, that an arrow component, mesh component, character movement. And this wasn't, they were from the class that they were. Um, so basically, these you notice that they are inherited. So they are using another class, probably the character class itself. In this case, they've added a mesh, and no, not a mesh. They have added a camera boon and a follow camera. And this is what you'll see in your third-person character for the most part. So things that they're using from the character class that they're extending, they've added the camera boon and follow camera. Capsule component. For a purpose, so this is collision. So there are, jump back to Unreal. Here's the component tab. If I click add right here, if I type in collision, you can see there's box collision, capsule collision, sphere collision. So these are collision pieces. So what you see and how you collide in the world are two different things. Basically, what I'm trying to get across. Back here, again, the mesh is the skeletal mesh that represents the character. Follow camera is the camera that they'll use in game, and the character movement is a component designed basically to handle movement concerns out of the box, and it's also networked as well. So if you wanted to replicate, it's set up to do that automatically as well. So when we talk about the constructor script, there's the idea of the constructor. Basically think of the constructor as when the object is created, it needs to do this. In Unreal, it does a little bit more. Anytime there's a change to its properties, or when the class is spawned at runtime, this will get called. So a good example that they think they give, I think the next slide, is they are setting so they basically have a material type. They have a material that they want to apply to the model, and this is a variable, basically, that they've created. And whenever this gets updated, it's going to change the material on the object itself. And this is kind of like part of what you can do with the constructor script type scenario. But really, what we're going to be working with a lot more are going to be events. And you've already seen begin play, so when the game begins, this gets kicked off. Tick event, this will happen every single frame. So this is adding an add actor world offset. So this is basically trying to move the object down the x-axis like every hundreds. Every second, it should moving about 100 units every second. Delta seconds, basically, those are Unity. This is delta time, effectively. This is how long it's been since the last frame was kicked off. And by multiplying this way, we become frame rate independent. You need to be careful with the tick event because you want to use it when necessary because it can perform performance. There are things that you don't want to do in the tick over and over again. Collision event. So again, we will create the collision components in here. There's three that you've seen so far. Actor begin overlap, actor end overlap, and then hit. For our purposes, you're going to use a lot begin overlap, end overlap, and there's versions of this for component, which we will use this week. Event hint is like the grenade launcher, the grenade that gets thrown out, and that basically is I've hit something. What do? Do I bounce? Do I explode? Do I do something weird? that's the scripting based on when it hits something, and you can tell other actor right here is an other component giving you information about how things got hit. So again, if we're talking about like a grenade and we want to leave a decal behind after our hit, we can go the hit location in normal and apply that to the decal to put it in the right location. Master range, I'm going to skip this because doesn't really work as expected. There's a lot more underneath the hood that you need to do in order for these events to actually kick off. Spawning actors. So when you spawn an actor, there is a spawn actor node, and it's going to ask for what class, like what the class of the actor that you want to spawn, and that includes C++ and Blueprint classes at all time. Where do you want to spawn it? And basically, this is here they're getting an actor transform. So you're wiring from one type to another. Jumping back to Unreal. I'm going to create a variable here just so you can see it. There's a variable types, and we can basically there's a boolean, byte, integer, 64, float, name, string, text. All right, so name and string are Unreal strings that for specific purposes. They're variants on there's specialized strings. Rotator, anything dealing rotation is going to deal with a rotator, and there's a reason why it's called that. It's a tech debt from Unreal Engine 1 still. And then there's the transform. This is again the transformation including translation, aka where it is, rotation, and its scale. You will find there are a whole slew of different structures that you might be using. There are a whole slew of things such as you might use the interface or nums. And then there'll be object types, other things that you may want to reference to. We'll come back to this one moment. The big one that you will probably use will be vectors. Transformations depends on it. Floats, integer, byte, booleans you'll use. All right. Let's back to the slides. Destroying actors. There's a node basically here to destroy an actor. Just a note, when you call this node, if there's anything else on the end of this node, it's not going to get called. It's not going to operate because the object's already been destroyed. So it's one of the oddities of this. There is a branch here. Essentially, this is the if statement, and basically the condition for it is plugged in right here. And this is one of those weird things if you're used to writing C++ or C# or Java code. Creating the Boolean outcome, basically writing the Boolean, the conditional statement in node form. We'll work with that over time. And this is if this is true only, then destroy the actor. Otherwise, it doesn't care. It doesn't do anything. But this is your if statement right here. We can get all active all classes, and what's going on here is that we ask what type of class. So later on, we'll do a coin collection, and one of the things that you'll do is you'll actually make a collectible class that is the root for anything that is actually collectible in your game, and you'll use that to basically build all the basic functionality in that class, and then basically the other the children classes basically is like what do I look at? What do I look like? What do I have any little animation pieces? Stuff you can implement there and just leverage the code that's already been built already. It's using set actor, hide it, hidden in game. We'll talk more about that later. Referring to actor. So what they're talking about here is that there's a variable type here. We can actually go and be like, hey, we want actors. All right. So there are four. Basically, there's always going to be four options. Object reference. So this is something it'll either either be something in the level already, or it'll be a component. It'll be something a component that you have assigned already. Um, Class reference, basically, this is like, again, like the spawn. We don't need an existing object. We want to create a new existing object. So we need to know what class of what type it is. And don't worry, like you will get specified in those classes very quickly. Beyond, like, again, I think they showed a character being spawned. I mean, you could have multiple different characters. Like, think of the Team Fortress 2 characters. Each one of them will have and they would probably be in Blueprint. So the final definition of the class would be in Blueprint. So what you spawn in as would be a class reference assigned there. Player input, we're going to pass through this really quickly because there's a new input system. There's a new input system with Unreal that we'll look at in more deep later on. And then there's also nodes again. This is nothing there that's going to help us. And then there is key mappings nodes that exist. And I'm actually going to jump in and be like, jump to the event graph. So we were like, hey, keyboard. So here is the keyboard event. So here is it's a button, and it's got press and release, and then there's more thing here in the key structure. What's in the key structure? I was trying to split it, but I can't. But basically, when the key is pressed, when is the release? Basically, here is Z in action. I don't think we need anything for this. I'm pointing it out right now, but we're not actually going to use this week. So, any questions before I move on with application of what we just talked about here? All right, so your first part of your lab, basically, I'm going to go back to the viewport here. Your first part of your lab, basically, is to recreate the hello world into a class itself. And that basically is going to be three components. A cube, which is going to be the platform. I'm going to add a box collision, and that's going to be the trigger volume. And I'm going to make sure these are they're not inheriting. There's no child. They're not. There's no child here going on. Because basically this, I know I need to make my box extents 50, 50, 50 to match the platform. The platform itself, I'm going to set down to 0.2. And for the trigger volume, I'm going to move it up just 50. The answer is 50. If I want to get picky, I could probably go, it's actually 60. So if I wanted just to sit on top of the platform, I can make it 60. That actually looks good. So again, default routine, trigger volume, platform. And the last thing I'm going to add is a point light. And just type in point. Here's the point light. And I'm going to move this up. I'll do 125. I'm going to go to Candelas because the 100. And then here we'll set it to something just red, just for our purposes. So I'm going to compile. I'm going to grab this and put it right here. Save everything. And I'm going to go to my content draw, and I'm going to grab the hello world. You can see that I've got this object in here. And I can go in now and be like, oh, I really want this like 3 by 3, 3 high. kept this range really big, but like we could, in theory, now on this object, be like, oh, on the point light, oh, the attenuation radius, maybe 500 is what we want. Maybe it probably needs to be 75. Inside, closer. So possibilities, options, and these are all settings I've made to this instance of the object. If I bring in another one in fact, we can be like, hey, I'll make this one green. And so I'll go back to the content draw, bring out another one. And we press play, we can turn around and see there are the platforms. All right, let's go back to let's go to the event graph. And for our purposes, we're going to work with the trigger volume. We don't need the tick, but we will need the begin play. So click on the trigger volume. And there are a whole slew of events that are common events right here. So I'm just going to go and use these to add what we need. Again, click on the trigger volume and uncode and overlap. And I'm going to bring begin play down here closer. Again, we're going to click on the point light, and I'm going to click and drag and get a reference to the point light. And then for our purposes is going to be again, set visibility. And I'll wire this in here, wire begin play into here as well. This is begin overlap. Break this link. Hold on. Easier for a moment. So here we go. So now on begin play, the visibility of the point light component is going to be turned off. When we enter, we can also plug that in here as well. When we exit the component, it'll do that as well. So I'm going to grab this down just a little bit. I grab these two, make a copy of them, so that when I bring this back here, I'll plug that in right there and turn on visibility. So on begin overlap, on component and overlap, and begin play. These are the three things we're going to be using. Now I can literally go into the third person mount. You can turn around, you can see that they are not on, but there's the one I created. There's the red. And that's pretty much how you're going to complete the first part of your assignment. Just basically, we're going to build a class, add components, and you can drag it into the world and do what you need with it. So far, so good? Okay. I'm going to save everything and I'll close this. I'm going to create a new empty blueprint class. It's going to be an actor. I'm going to put in content, and it's going to be called sliding doors. Okay. So we go to lab 3. And so basically, this is what you're building. Basically, there's going to be 6 cubes, and then basically 6 cubes and one collision volume. And that collision volume is going to be big to catch both player going through the doorway on both sides. So if I remember, I'm going to start with building this. I'm going to add a scene. This is going to be the frame. I'm going to add a cube. And I'm going to make this size, again, so this is our forward direction. So I'm going to slide the door. What I'll do is I'll essentially slide the door on the y-axis. All right, so I know I need this to be 4, 6.2. I'm going to duplicate this. So this is going to be the bottom. This will be the top. So I'm going to bring this back to 1, and I believe 300 is what we wanted. Oh, just 6. My God. I had 56. My apologies. Okay. The next thing that we want is essentially, I'm going to duplicate the bottom again. This will be the top. And this is going to be the side. So we know that it's not going to be 4.0. I'll bring this into type in 3.9. Just so it's not overlapping. I know I want this to be a size of 1. And I believe it should be a size of 3. I'll set it at 150. And then I can set this at 250. And I can duplicate it. And I put it at negative 250. So I'll drop it on that side over there. I'll duplicate this wall one more time. And this is going to be door A. Because we're doing both doors. And I'm going to bring this down to 3.75. So we have a nice lip. And we'll do, and we know this is a size of 2. And this should be in at 100. So negative 100 on this side of the door. It'll be 100 on the other side. In one moment. So we'll duplicate this. And I'll just put it at 100. So not door A, but door, this is door A. All right, I'm going to flip it back and forth. So here's what we've got, what it's looking. Not perfect, there are things that we're going to deal with. What we do know is that this is going to slide about like 275. It's going to give me something that gives me a nice lip. So that's a difference of 175 units. So since we know that that's going to be a variable. It's going to be of type float. Be slide amount. And then we're going to compile so that we can then put in 175 down here, and we'll recompile to have it take. So the other thing that we need to do, for the setup, is that we do need 2 vectors. And this is going to be door A start. I'll duplicate door B start. So we need to know this so that we can know how far it needs to. Basically, we need to know this because basically we're going to slide this back and forth in a looping motion. So we need to know where it starts and how far it's going to go. So let's go into the code right now. We don't need begin overlap 10. But I'm going to grab door A start, get door A start. No, I'm going, sorry. I need to set door A start. And this is going to come off of door, we'll start with door A. Door A. And we're going to take a, and we're going to type, we want to get its relative location. Now I did this multiple ways in the day section. So if you are curious what they saw, go right ahead and look at the video for tutorial. It's in part 2. We're going to set this as well. Door B. Here's again relative transformation. We'll wire these together, and we're good. So when we start, these values are going to, their location are going to be in there. And this is going to be important because we're going to use this in our calculation, how to slide the door. All right. I'm actually going to create a function, and then we'll call it slide door. And we're going to give it a couple inputs. So the first one is going to be, again, type an act. Yeah, it's going to be a type of actor. No, it's going to be, oh man, static. Yeah, we want a static mesh component. And this is going to be the door. Okay. We need door percentage. And this is going to be not a vector, but a float. No, float. There we go. We need to add another variable. Next thing that we need, next variable we need percentage. We need to know which direction we're sliding in. So add another variable. Float. This is the direction. think I'm missing one more thing. No, you know the slide amount is here. All right, I don't need the direction here. Yeah, it should be okay. And then slide amount will come in down here. First thing I want to do is multiply them together. And I'm going to add all these together. So the percentage, so direction is going to be 1 or -1, but this is going to come in off another node. Slide amount is what we assigned. And again, we'll just go down. We want to expose it. We can change that right here. So basically, this is figuring how far. Oh, I know what I did wrong. I'm missing the start location. That's what I was thinking. So this is going to be I'm going to make this. I'll make this the vector. Direction percentage. That makes more sense. Direction percentage. There we go. So we're going to multiply all that together, and that'll be our change. And then we'll take our start location. We want to add them together. And actually, what we want to do is break this link. And then we want to split the struct bin. Okay, because basically all that we really want is to add the y values together, because we know we're only moving on that axis. Later on, we will make. So now that we've got that, we can take a reference to our door, set local, relative location. All right, so there's relative location, aka the local location. There's also the global rotation. Basically, what we're doing right now is we want to move based on the frame, where the frame is, and not like again, if we move on the y-axis here in the frame, doesn't matter. Again, the rotation of the object won't matter. That's why we're doing it this way. And this is going to plug into. Actually, this needs to plug into. Split this. This is going to be the y value. Why is this? Okay, I'm going to do this differently again. So we multiply these two together. And then we will multiply these two together. That one bit. We will delete this node, and this is going to multiply. Not multiply. We're going to add. Y location. And then this will get plugged into Y. This will get plugged into the X if I can. So basically, we'll call this node to slide the door. Um, I know I'm not. I know I'm going to compile, make sure we're all good. We are. So let's go back to our event graph. So the first thing that I'm going to do is I'm going to click. What did I forget? I forgot to go. Let me go back to the viewport. The thing I forgot to add here was the collision. So we'll take a box collider, and then I'm going to set this 50-50-50. And then I can play with it. This will be 8. Do 6. 8 will be here, and this will be, I think, 3. We'll bring this up. It's close enough for what we're trying to do. All right, so this is going to be the collision trigger. And we'll go back to now our event graph. Where's the collision trigger? Here we go. We'll right click on begin overlap. And then the next one is, we'll click on it again, end overlap. All right. We're going to right click here and we're going to type timeline. And essentially when we begin the overlap, we're going to play. And when we end the overlap, we're going to reverse it. So when again, we're thinking single player right now. So if there's more than one person, doing multiplayer, this will not work as expected. We'll click on it. And I'm actually going to give us a length of 2. The next is we need a track. And basically we want a float track. We can do vectors, events, colors, whatnot. But right now we just need a float track. And here is pretty much like everything. We'll right click, add a key to the curve float. And we're going to rename this. This will be percentage. And I can right click on these objects to bring up where it's time and value. So basically time, I want that at 0. And this one, I want this at 1. Just do this. Value will be, sorry. The value here is 2. All right. I'm going to compile, save all. I'm going to bring this over here. And I'm going to rename this Flying Doors and make this bigger. And then where's my start? Go to my content draw, put my sliding doors down. So I'm going to put one copy here. I'm going to copy and paste, I'm going to move it, and I'm going to rotate it 90 degrees. I want to rotate it 90 degrees on the z-axis so that we've got one facing for us and one right there. And so basically what I want to show off eventually is that we can build our object locally and then have it perform based on those local calculations. Go out and perform in the world based on its local rotation. So, any questions so far? Okay, I need to stop the recording.